So we are solving the assignment 8 for the training undertaken operation and planning of power distribution system. So the first question given is, for a feeder with a uniformly distributed load, a fixed capacitor bank rated at 3/4 of the total reactive load and located at 3/4 of the distance out on the feeder from the source gives load reduction of. So the calculation is like this. So we have used this formula delta PLS, that is loss reduction in power, that is delta PLS equals to 3CSX1 divided by 1 plus lambda square, that is alpha, into 2 minus x1 plus lambda x1 minus c. As per data, the load is uniformly distributed, so lambda is equals to 0, c is equals to 3/4, that is degree of compensation mentioned, and x1 is equals to 3/4 distance. So now putting all the values in the formula, we are getting the answer 0.84375, and in percentage it is 84.375 percentage. So the answer is C. Now the question 2, they have given some data, and out of which we are using some data for this calculation which is required. So in question number 2, we have to determine the active power supplied by the feeder. So for this, I require the current carrying capacity, that is I1 is equals to 300, power factor at the time, so 0.7 lagging is the power factor, load demand remains constant. Now, so power supplied by the feeder is root 3 VL IL cos theta. So root 3 VL is 1100, 11 kV, so 11,000, and IL is equals to 300, that is current supplied currently, so I is equals to 300 current, and the power factor mentioned is 0.7 lagging. So the answer is 4001.037 kilowatt. So answer is D. Now the third question. So third question they have asked like, yes, determine the load demand supplied by the feeder in MVA. So it is simple, S is equals to P divided by power factor. So power is equals to 4001.037 kilowatt divided by 0.7. So answer is 5715.767 kVA. So it will, in MVA it is 5.716 MVA. So answer is C in third question. In fourth, determine the power factor of the feeder after capacitor placement. So after the placement of the capacitor, as P remains the same, we have to calculate S new, that is current remains current, we have to drop down to the value of the degree of thermal ampacity capacity that they have mentioned is 230 ampere. So current is reduced to 30 ampere. So accordingly S new is calculated as root 3 VL IL. So S new is equals to 4382.088 kVA. Now the power factor, as load remains the constant, so P remains the constant, so power factor with new kVA rating is 4001.037 divided by 4382.088, so it is 0.9130 lagging. So answer is A. In question number 4, answer is A. Now question number 5. So question number 5, we have to determine the value of capacitor bank rating. So S is equals Q is equals to S into sin theta. So Q is equals to 4082.04 kVA. Now Q new, that is the new value of the kVA rating. So it is 1787.7146. This is after the placement of capacitors. So actual capacitor bank size is equals to QC is equals to Q minus Q new. So it will give you the answer 2294.325 kVAR. So answer is D, this 2294.074 kVAR. Answer number 6, determine the magnitude of voltage drop that we have to calculate. So delta V is equals to I into R cos theta into X into sin theta. So sin theta is equals to 0.4079 and cos theta is equals to 0.9130, that after the placement of capacitor bank. So R is equals to 2.8, that is 0.7 multiplied by 4 kilometer length, so it is 2.8, and 0.5 multiplied by 4 kilometer length, so XL is equals to 2.0. so the calculation with the calculation of this, delta V is equals to 775.606 volt. So answer is 791.414. so we have selected answer C in the 6th question. Now for the 7th, it is already calculated in question number 4. So S new is equals to 4382.088 kVA. So by converting this into MVA, so it is 4.38 MVA. So answer is D in question number 7. Now in question number 8, we have to find out the value of reactive power supplied by each capacitor. So power factor cos theta 1 original is 0.75 and improved power factor is 0.9. So Q calculated by this formula is 636.16 kVAR. As mentioned, it is 3-phase load and star connected. So power Q is equals to 636.16 divided by 3. So it is 212.053 kVAR. So answer is A. Now in question number 9, it is mentioned as we have to find out the value of capacitor. So we have calculated XC, that is V phase square divided by the reactive power Q. So it will give you the value of XC as 190.2040, and with the help of this XC we can calculate C as 16.735 microfarad. So answer is B, 16.73. and now the reactive power compensation, the outcome of the reactive power compensation is reduction of power loss and reduction power factor correction. So these are two options which are right, so I have selected them. Now I am submitting the assignment. So after the submission, it will give you this kind of screen. So thank you for the assignment submission. So we have submitted the assignment.